All right, this is the last topic that we have in lesson 8, which is area of parallelograms and trapezoids. So far we've talked about area of rectangles and squares, we've talked about an area of a triangle, and we've also talked about the area of circles. And we kind of wrap it up here with parallelograms and trapezoids. Now before we start with the how we find the area of those, we actually have to know what a parallelogram is. A parallelogram, by definition, is a four-sided figure or a quadrilateral with both pairs of opposite sides parallel. So a typical looking parallelogram might be kind of that leaning rectangle is usually how we picture those. So notice that in this diagram, and if I drew that, this is just a sketch, but notice that this side and this side, I try to make those look parallel. So there's one pair of parallel sides, and then these sides appear to be parallel. So you have two pairs of opposite sides parallel. That's a parallelogram, that leaning rectangle. Now a trapezoid is also a quadrilateral, a four-sided figure, but now we only have one pair of sides parallel. So a typical looking trapezoid might be something like this, where we have, and I'll outline this, where one pair of sides are parallel, but the other pair is not. So in other words, and remember what we mean by parallel. Parallel means the sides will never touch. So just to emphasize that, this side and this side, if those sides kept on going, they're never going to touch, they're parallel. And the same thing with this side and this side, they're parallel. Over here, these are parallel, they'll never touch. But the other two sides, though, would touch if they kept on going. So in other words, they would intersect. So trapezoids and parallelograms. Now in example 1, it says find the area of this figure. Now what is this figure? Is it a trapezoid or is it a parallelogram? It's a parallelogram. So one way I could do this, typically, and there's really two ways you could think about this. One way we could do this is we can always split it into a parallelogram or a trapezoid. We can split it into two triangles. So for example, I'm going to outline these. So this that I have outlined in the yellow is one triangle, right? And then I'm going to outline the other one in green. So I have two triangles that were created when I split this parallelogram into two parts. Now I could have drawn that dotted line from the other corner to corner and split it that way. It doesn't matter. Now let's take the yellow one. Now that's a triangle, right? So the base is 8. So in other words, for a triangle, we take the base times the height and we divide by 2. So for the yellow triangle, that's equal to 8. What's the height of the triangle? Don't say 5. Don't say 5 because that's slanted. What's the straight up and down height? So in other words, from here all the way down to drop that down. So from here to here, what is that? Well, it's 4, right? So I take 8 times 4 and I got to remember to divide by 2. So that's 32 divided by 2, which is 16. So the area of the yellow is 16. Now how about the green? The green one, the green triangle, the base is 8, same thing as the yellow. What's the height of the green one? So in other words, straight from top to bottom, straight up and down, it's also 4. And divide that by 2. Well, you've got the same numbers, don't we? So 32 divided by 2, which is 16. So the area of the green is also 16. Add the two together, and the area is 32. There's not a label on this, but we'll call it units squared. 32 units squared. Now, is there another way you could have done this? And there is. So in other words, if I take, I'm going to erase what I have here. Some of you may have divided the parallelogram like this. Maybe you dropped a line straight down, made a line straight up, and now you have two triangles and a rectangle then. So in other words, if I outline those, so I have my rectangle in the middle, which is 8 by 4, right? And then I have my two triangles on each end. So I have a triangle there, and I have a triangle there, where I know the height, and I can figure out the base of them, okay? So, let's see, with a triangle, and actually here I'm looking at this, do we have enough information to do that way? So in other words, look at the green rectangle. Can I figure out what this distance is? We know that all the way across is 8. Same thing with the top here. With this particular diagram, we don't have enough information to do that. Now, if we did, we could certainly split it up that way. So that way probably wouldn't work in this particular example. All right, is there another way we could have figured out the area of this parallelogram? If I were to take this parallelogram and push it and straighten it up so it became a rectangle, what would the dimensions of it be? 8 by 4, 32. So you could have done it that way, provided that we're given enough information in the height. All right, example 2, find the area. Now this is a trapezoid. Remember, for any parallelogram or any trapezoid, I can always split it corner to corner into 2 triangles. I can always use that method. So on the top one, I've got that yellow triangle, and I also have that green triangle in the bottom. So for the yellow one, I'll just put yellow. That's equal to the base of 9 times the height of 4, not 5, divided by 2. 36 divided by 2, 18. And for the green one, I would have 15 as the base, height of 4 divided by 2, which is 60 divided by 2, which is 30. So my yellow one was 18, my green one was 30. I add those together, 30 and 10, 40, add 8 more, 48 units squared is the area of that trapezoid. All right? Would I have enough information to do it another way? So I'll erase this. And I've got my 5 over there. Could I have dropped a line straight down, dropped a line straight down, where I have a triangle here, a triangle there, figure out the area of each of those, and then also figure out the rectangle in the middle. Could I have done it that way? And here we do have enough information to do that. What's the dimensions of the rectangle? The rectangle would be 9 by 4, so that's 36. And the triangles here, let's see, can I figure out what the base of each one is? They're split up equally. 9 plus 6 more, so each of those would be 3. So the base of the triangles are 3, the height of each one is 4. So let's see, 3 by 4 is 12, divide by 2 is 6, and then add the 3 parts together, 36, 6, and 6, and I get the same answer of 48. Again, you could have done it that way, but you never can go wrong either with splitting it into 2 triangles. All right, example 3, find the area. What is this? Is it a trapezoid or a parallelogram? Well, it doesn't matter. I can just split it corner to corner and do that same thing. Here I have a triangle, and I also have a triangle here. And I can go through the same process that I have in the previous 2 examples to find the areas. Now you could also split it like this, drop a line straight down, and we have enough information to figure this base out right here, right? All the way across is 10. This part is 7, so the base has to be 3, and the height is 4, right? So I can figure out the area of this triangle. Let's see, 4 by 3 is 12, divided by 2 is 6. What's the area of the rectangle? 7 by 4, 28. 28 and 6, 34. 34 units squared. Now it'd be helpful if you did it the other way and also see if you got the answer of 34. So by the other way, I mean if you split the trapezoid into 2 triangles, you should get the same answer. So this is just a wrap up of area, and it's area of parallelograms and trapezoids.